This is the 8th question of TMUA 2023 exam, paper 2. The question says a student draws a triangle that is acute angled or obtuse angled but not right angled. Okay, so let me draw either an acute angle or an obtuse angle. Okay, but not both. The student counts the number of straight lines that divide the triangle into two triangles. At least one of them is a right angle. At least one of them is a right angle triangle. Okay. Which of the following statement is or are true? The student can draw a triangle for which there is exactly one such straight line. The student can draw a triangle for which there are exactly two such straight lines. The student can draw a triangle for which there are exactly three such straight lines. So if in the case of acute angle triangle, I can draw this line 1. This line 1. Okay, with red I am drawing. Let me call it as 1. Line 1. It is dividing this triangle into two right angle triangles. So it is possible here. Similarly, I can drop this altitude here, line 2. Again, this altitude is dividing this triangle into these two triangles. And similarly, this triangle here, this altitude here. Again, this altitude is dividing this triangle into right angle triangles. So I can get exactly three such straight lines from this statement, from this acute angle triangle. Now, what about obtuse angle triangle? If I drop an altitude here, this is dividing this triangle into two right angle triangles. Can I drop an altitude from this point inside the triangle? No. Drop an altitude, I need to extend this line and drop the altitude like this here. You are not drawing inside, so it is not dividing this. This altitude is not dividing this triangle. Okay, so this is line 1 I've got. Similarly, from here, if I have to drop an altitude, I need to extend this line and drop an altitude here. Again, this altitude is not dividing this triangle into two parts. So I might think that that I have only one option from here, and I might go and mark 1 as the answer, because 1 is definitely sure that there is one such straight line that is possible. Here there are 3, here there are 1. I am not sure which triangle I am drawn. It can be acute or obtuse. So in acute also there is definitely 1. Here also there is definitely 1. But there is a catch. I am not dividing. There is also a possibility that I can divide this obtuse angle in two right angle triangles such that one of them is right angle, the other is not right. Here both of them are right angled. In this case also both these triangles were right angled. But in this obtuse angle situation, if I, let's say, diagram here. Let's say from here, if I draw this line like this is 90 degree. So again, I have this 90 degree, I am dividing this triangle into two triangles such that one of them is 90 degree. So I can get this line. Similarly, taking this as one of the sides, I can then drop a 90 degree angle like this. So, and I have already drawn the altitude. So even in the obtuse angle triangle, I can get this altitude, which is one of the line. The other two lines are which are 90 degree to the end lines, which are not the longest line of the obtuse angle triangle. Okay. So if you want, I can give you, and actually what I'm going to do is I'm going to draw these 3 lines also in this obtuse angle. This is one of the situations. The other situation is this. And finally, the third situation is this. So in all these cases, this obtuse angle triangle is divided into two triangles such that at least one of the triangles inside is a right angle triangle. So in obtuse angle case also I get 3. So whether I make acute or obtuse, in both the cases, the student can draw a triangle for which there are exactly 3 such straight lines, which will divide this triangle into two triangles, at least one of which is a right angle. So answer option 3 is the correct answer, which is option D. Option D is the right answer.